Okay. And would you say that like when let's say you have a vision and you're trying to you have like all these things like, oh, I gotta learn this and that and that, would you say that's like it feels very heavy?
If it feels heavy,
Like, like let's say you have a vision, it's like, oh, I gotta
yeah.
learn this framework, this library. Like, does that thought like feel very heavy?
Um, I mean, a little bit. Like,
Okay.
I know how to code in the sense of like if you're like, oh, like put together some code to calculate the APR of a credit card. I could probably put something together. But if I have to like put a website that communicates with backend and like for instance, like if I was using like DB Mongo, like I barely know anything about that side, like how Deep Mongo works and how that works with the front end, and so there's a whole side of this thing that I have no knowledge of, and I have a lot to learn still. Does that make
Okay.
sense?
Okay. Okay. Let me think about this. Because this doesn't sound like programming specifically. That sounds more like hooking up various systems together. Um,
Sure, sure. It's yeah, and it's kind of been like the nature where I've go to like learn the basics of things. Like there was one course I took particularly for JavaScript. I thought it was really good, but then I kind of like fell off and I didn't continue with the course. I've struggled to be disciplined without an environment that has very good what is like structure in like a not so structured environment. And I know this, I can already tell this feels like this is not going to be not so structured, which is fine. But I know those are just some of the things I have to overcome if I want
yeah.
to do this professionally.
What do you mean by structure?
Like I think I struggle with kind of like executive functions, the things like related to like discipline.
Okay.
So if I'm just like if I have to tell myself, hey, I'm gonna wake up every morning at 6 a.m. and code for an hour without I will struggle with that. But if my job tells me I need to show up at 6 a.m. and code for an hour, I won't struggle because the structure of a job will like I'll be very consistent in that. Does that make sense?
No, I know, I see what you mean. Okay. Yeah, so like the thing about these sessions is that like it's very self-directed. Like I'm not gonna say like,
Yep.
okay, for homework, I want you to do this exercises, but if you if you want me to give you these homeworks to force you to do stuff, like I can do it. It's very easy on my end.
Okay. Fair enough. I say I probably would do better with that kind of situation.
Okay, okay,
But either way, I appreciate anything you have to offer. I want to be
okay.
the best student I possibly can and get the most out of this, and continue to grow and become a good web developer.
Okay. Okay. So in terms of structure, right? If you believe, because I'm trying to tailor these sessions to you, if you believe
Hmm.
that having good structure, like having goals, having like at least having like homeworks after each session, so you know what to work on before the next session, if that helps you, like I'm happy to help you with that.
Yeah, I think it would help me.
Okay.
Yeah, 100%.
Okay. Cool. Cool. Okay. Mm, okay. In your case, I'm going to okay. I need to like calibrate with you first because I'm not sure where
Hmm.
you're at. So I'm going to
Sure.
give you the what I would give absolute beginners, but I suspect I have to like go quickly with you. I feel like you're going to pick up the pace really quickly, in which case I will just progress really quickly. So I'm just going to start with
Um,
something and we'll see where that takes us.
sure. I can give you my GitHub. I think it has like a collection of kind of all the random stuff I've worked on over the years.
Oh, that's not going to
Um,
help me.
okay, no problem.
Yeah, there's a certain way that I think about programming fundamentals.
Sure.
And yeah, and I think it's best that I see you like program in front of my eyes first for a bit, and then that will help me calibrate.
Sure,
Um,
sure.
do you use VS Code by chance?
Yes. Yes, I do.
Okay, so usually I start out people by using the web browser editor, but in your case, I think I'm going to use VS Code Live Share immediately because that
Sweet.
lets me code with you, and I can get you. We can move much quicker that way. So give me one
Okay.
second as I set that up. I've
Okay.
actually just done this with another person just now, and I feel like it is much faster. But you're gonna feel like you're on your toes the whole time. I'll warn you now.
Okay.
Let's see, let's pull this up. Yeah, okay, just give me one second.
Sure.
Open folder, project. Live share. Have you used VS Code Live Share before?
No, I haven't used that before.
Okay, so it's the first time. Okay. Hopefully it's pretty intuitive.
Okay.
I've okay, I think I got it. I'm gonna send the live share link in chat. I recommend opening it in the app.
Okay.
Okay. And let me know once you
And
open it.
so okay. So would I just put it up in the top like I guess we call it search bar? Or
I believe you have to open in a web browser first, and then it's gonna ask you, do you
okay,
want to
okay.
open it in the app? Yeah, you should say yes for that.
I see, I see. Thank you for
Yeah.
clarifying.
Yep. And once you do that, let me know, because there's one extra step you have to take.
Always open. And then it's asking me to install LiveShare extension, which should be fine.
Oh yeah, you gotta get the
Uh,
live share extension. Forgot about that.
sign. I don't think I've ever like made a login for VS Code.
Do you need an
Let me.
account for it? I don't remember.
It's asking me like you want to continue as anonymous or sign in. I guess for the sake of this for speed, just continue as anonymous.
Yeah, that worked for me. And while you're installing extensions, if you could also search the extension PYRET pirate and install that extension as well.
Okay, there for now. Extensions. Apologies. Spell that for me one more time. It's PYRAT,
Yeah, PYRET.
right?
Oh, EET, like E for
ET. Okay,
elephant. Yeah,
there we go. That's why it wasn't coming up. All right,
it should
and
be like, yep,
the Pirate Interactive Editor.
yep.
Okay,
Okay, let me know once you have that installed.
it's installing now.
Okay. And do you see the VS Code live share?
Hold on. Let me
There's a file
see.
that should be called
Oh,
sunset.arr.
I see. It says I'm seeing Live Share Workspace with a spinning thing. So give it a second. Joining collaborative session. Waiting for host approval.
For host
Okay,
approval. It's asking me for approval.
I think so.
Hmm. No, I don't see the. This isn't running as smoothly as just now. I'm gonna send a link again. Maybe
Okay.
they'll.
Should be installed now, right? Let's see. I'm gonna cancel on that. And okay,
Yeah, I just sent the link again on chat. If you could click on that.
got it. Wait,
Hmm.
I need to let me do this with the chat. Okay. Did not launch. Okay, let me try reopen with visual. Uh, yes. Open. Sign into continuous anonymous. Okay, so let's kind
Yep,
of
I
go back to.
see.
Okay,
I see your request now. I don't know why I didn't ask just now, but I've just accepted your request, and I believe you should be
I
showing
think
up now.
I think we're good. Yeah. Okay.
Look, do you see a file sunset.arr?
Yeah, I do. Sunset.arr.
You can see the text hello. Can you see this?
Yeah. Yes. Yes.
Okay, just to test and stuff, could
Um.
you enter a new line and just put like the number five? Perfect. I see it. I see it. Okay. Is there a blue run button at the top?
There is.
Okay. Can you click run? It should give you back five.
Yep. There we go.
Okay. All right, so I think you're probably my most advanced student. I'm going to go quite quick, like compared to an absolute beginner. If I'm going
Okay.
too quick, just let me know and we can slow things down.
Okay.
So here's my goal. I have a certain approach to computer science that I believe is very fundamental, but I think that the traditional computer science courses, whether that be like university or boot camps, I believe they don't teach things which I consider fundamental. So my goal is to rebuild your foundations,
Okay.
incorporating some ideas which I consider to be fundamentals. I
Okay.
know you're probably wondering, like, what could I possibly say that is fundamental? But you'll see.
Oh, I'm sure there's plenty. Like, yeah. It's not. I feel like a lot of my teachers are more practical and less theory. So yeah, I'm sure there's plenty you could teach and show me.
Okay. All right, let's begin. So, okay, when I click run, you cannot see that I click run. So whenever I say click run, just click run. Okay.
Okay. Sure.
So I've added two numbers and I'm going to click run.
Okay.
Nothing surprising, right? You get a number back. I can add
I
a
don't know.
third number.
Oh, I see. Okay, I do see like the 2 3 4 5 plus 4 5 6 plus 2 3 4 5.
And can you click run now?
Oh, yeah. Okay, sorry.
Do you see 5146?
Yes. Yes.
Okay, very good. Okay, so I'm going to change one of these plus signs to minus. Now, if I click run, what happens?
Uh, it said reading this expression errored. Okay.
Okay, what does it mean?
Uh, plus and minus operations or same grouping level at the parentheses. Operation to make the ordered operations clear. Um. Okay. Hmm. It seems like it doesn't like that these two operations are at the same levels and that there's not parentheses to clarify what takes priority.
Okay, so if you, so okay, could you fix this for me? How will we fix it?
Sure. So, oh, come on.
Okay,
And then I'm gonna hit run.
yep, 456. Perfect. Okay, so orders of operation in conventional mathematics, I don't know, do you know like BITMAS or
Yeah.
pandas?
Yeah, PEMDAS,
Okay,
yes, sir.
that does not exist here.
Mm,
Why does it not
that's
exist?
no.
Because in programming languages, there are many more operations than six. There are very many operations.
Okay.
And in some programming languages, you would have to memorize all of their conventions, which comes first and which comes second, and it's very painful. But this language is designed for beginners, and so that convention does not exist. You have to specify it by hand, by surrounding parentheses.
Okay.
Okay?
Yeah.
All right. So far, that's the order of operations. Next, I'm going to introduce worded operations. So if you click run now, it should give 5. This is giving the minimum number.
Okay.
So if I make the first one bigger, it will give 6 now, because now 6 is
Yeah.
smaller.
Yep.
So there could be an infinite number of math operations. We can't use symbols for everything. So naturally, we use words, where words is just combinations of symbols, right?
Yeah.
So as programmers, it's so easy to make an operation, and so we can make many, many operations, as many as we want. So far, so good.
Yeah.
Okay. This is pretty standard stuff. Next, I'm going to introduce variables. So far we've been using this as a calculator. I'm exploring the laws of arithmetic, where
Yeah.
the orders of operations must be specified all the time. Now we're
Mm-hmm.
going to move on to algebra. We have variable substitution. If I run this, we get 1.
Yep. Okay.
Change x,
Hold on.
change x equals 2, and I get 2. Now,
Okay.
notice how, I don't know if you noticed this, I've never been writing print statements. Whenever I write something, it just works. You just get an answer,
Yeah, that's
right?
interesting that you don't have to like say print and then put X in parentheses or anything like that. You just say X and it knows to just give you what
Exactly.
X represents. Okay.
If I click run here with 3 x's, I'm going to get 2 3 times. You see that?
Yeah. Yeah.
Okay.
Okay.
Now, why is it like this? It's a bit historical, a bit pedagogical. The historical aspect is that this language was inspired by a descendant of Scheme. Have you heard of Scheme?
No, I have not heard of scheme.
Okay, it's like a programming language with a lot of parentheses. So like your program looks like this, like like that. I don't know if you've seen
Okay.
languages like that before, but like, there are languages that look like that. They have a lot of parentheses. So in those kind of programming languages, there are like Scheme, that family of language. Well, I should say Lisp, that family of language. It's pretty like one of the oldest programming languages made in MIT. originally, I believe, used for artificial intelligence, back when
Okay.
artificial intelligence meant something very different. It's a
Yeah.
very mathy language. The language is very mathematical. The idea is that your program is a function. You write something, it computes something, and it gives something back, right?
Okay. Um,
So, yeah.
what about the little CR at the end of each line?
That has nothing to do with the language. That's a carriage return. That's an artifact of Windows.
Okay. Okay. Gotcha.
Yeah, so pretend that's not there.
Okay. Interesting. So like if I was doing this on a MacBook, I wouldn't see that.
The reason why you're using it is because I'm on Windows. When I hit enter, Windows puts a carriage return. Like on my
Okay.
screen, I don't see it. I know you see it though.
I gotcha.
Yeah.
Okay. No,
Okay,
fair enough.
just like yeah, block it out. You gradually block it out as you see more of it.
Sure.
Okay. So anyway, so this is a this program that we're writing is a math function. When I write
Hmm.
X, it will actually compute that X as an answer and display it.
Yeah.
So the pedagogical answer is that as a beginner, I don't want to remember I have to write print to print something out. I can just write something and I'll see the answer immediately. That's the pedagogical answer to that.
Okay.
Yeah. Okay, anyway, so back to variables. So I can write x equals 2. Notice how if I write x and then x equals 2 and I run it, it's not going to like that.
Yeah.
There's a notion of time, right? Because I define it after, like if I define it later before I use it, after I use it, it's gonna complain. I haven't defined it yet.
Yes.
So there's order of operations but across multiple lines.
Yeah. So yeah,
Uh,
you have to define it before you call for it.
exactly. So this programming language, it reads from top to bottom.
Yeah.
Yeah, okay. So now I'm going to do x equals 3. Now, before we run it, what do you think is going to happen?
It's gonna give you three.
Okay, let's run it. Oh, you
Okay.
see the error?
Declaration name conflicts with it. Oh, okay. So it doesn't just overwrite previous declarations.
Hmm.
That's interesting.
Also, I just realized I made a mistake. I forgot to share. I'm going to share my screen, but it's for the purposes of recording, so the
Yeah.
recording will pick it up. But you can keep looking at your Visual Studio. That's fine.
Sure. Okay. Yeah.
Oh,
No worries.
yeah. Oh, classic mistake, forgetting to record. Oh my gosh. Okay. Okay.
Oh,
So
no worries.
this will have different behaviors in different programming languages. Some
Yeah.
programming languages will get 3, but here it says, no, you've declared it already. Why are you declaring it again? So the idea of declaring, it means this is X and it's going to be 2. Whenever I see X, I'm going to see 2.
Okay.
Um, it's like the Declaration of Independence, right? Like once you declare it, like it's declared.
Yeah. Yeah.
Yeah.
So, uh, well, my my natural question is like, all right. So what do you have to? What's the code you got to put in to tell it to? All right, X now equals this. And to overwrite a previous entered. I imagine we'll get there.
Okay. I believe there is a special operator to change it, but
Hmm.
I'm not sure what it is yet. But for our purposes, for at least for this session, we don't need it.
Okay.
But we will get to that in the future. Okay, so what we're
Okay.
talking about when we say like we declare something, but I want to change it now, that's the idea of mutation. But
Hmm.
and typically, like before I get to mutation, I usually want to go through a lot of fundamentals first because mutation introduces some stuff that are a bit tricky.
Fair enough.
Yeah, so that will come with time. Okay, so there's no mutation yet, and we can only declare something once. And as far as I'm concerned, this is a constant.
Okay.
And we can do things like this as well, where variables,
Yeah.
if we run this now, variables can use other variables. So like y equals x is going to see 2. X is 2, and then y is going to be 2.
Yeah.
And then y plus 1, y is going to be 2, so 2 plus 1 is 3. Okay, and these variables and numbers can mix and match. Right.
Yeah.
Okay, so this is pretty standard stuff so far.
Hmm.
Next, so now we have gone through the very early stages of the laws of algebra, where we can have variables and variable substitution. I'm now going to introduce another key idea of algebra, which is functions. So if you want to say something like f of x equals x plus 1, to do that in this language, it is going to look a little bit different from what you're used to. To declare
Oh
a
wait.
function,
When you say
yeah.
f of x, what does that mean?
Oh, so um, I'm writing this as mathematical notation, not as language notation. This is a
Okay.
function that takes in one thing, we call it x, and it's going to
Oh.
substitute that x, and it's going to add 1 to it.
Okay.
So I'm going to write this in this language, and it's going to look a bit funny. First, I have to write fun, f fun, fun for function. So when this language sees fun, it's going to say, oh, you're defining a function. Next, the name of the function, f. Next, parameters in parentheses, and then followed by a colon. So this looks like Python so far. Next,
Okay.
body. Finally, end. So now this whole thing is highlighted. We're telling the language this is a function, and the language is telling us, yes, you have just defined a function, and that's the scope of the function. So there are three
Okay.
parts. First is the name of the function. It needs a name so that we can refer to it. We'll revisit this later. Next is the inputs. Uh, Another word for inputs is parameters. We say this is the
Okay.
parameter of the function x. A function is fundamentally inputs to outputs. So we're saying this is the input in parentheses. This is the input. What's the output? The output is going to be take the input and add one to it. How do we get to the output? We call this the body of the function, right?
Okay.
Okay. Notice how there's no return. If you remember like JavaScript or Python, you have to write return. Here we don't.
So basically, when this function runs, it's going to just go through the lines, and whatever the result is, it's just going to know to return. It just returns that automatically.
Yes. If I click run
Okay.
now, nothing's going to happen because we have just defined a function. We haven't
Yeah.
actually used it. In mathematical speak, we say we apply a function. In programming, we say we call a function. So if I do like f of like some random number here, and I run it now, I actually get an answer back.
Yes.
Okay. Um, yeah. Notice that, yeah, there's no return. It just gives the final thing in the function. Some languages do this. This is one of them. In other languages, you have to write return.
So I'll say this, like for me, like the way you wrote out the functions, lines 5 through 7, is more what I'm used to. I know functions can be written kind of like how you explained on line 3, but that is, I'm not used to working with that style of function writing. Although like if I'm on Code Wars, I'll see that kind of style, and I'm like, man, I gotta like learn that.
Yeah, you don't really need to. So this is more like syntax stuff. Like in,
Yeah.
okay, I might be messing up the syntax. Like for example, in like JavaScript, you can say something like this, like more or less something like this.
Hmm.
But this, to me, that's not important. This, I call this syntactic sugar. It's just syntax made to look sweet, but like that's all it is. It's just syntax made to look sweet.
Yeah, I
Um,
guess I think of it like shorthand way of writing
exactly.
functions.
Yeah, but I wouldn't consider that part of the fundamentals. I would say that's like nice to know, right?
Yeah,
Okay.
I got you.
Um, okay, I'm going to go a little bit more. I do have to refresh the Zoom session in a moment. I have to send you a new link on Gmail, but let's go for 5 more minutes.
Sure.
Okay. Notice how there are two windows. There's a window on the left and a window on the right.
Hmm.
Okay, I want you to click on the window on the right, and I would like, and that is a text box you can write. I would like you to write
Yeah.
F off and then any number you want, and then click enter.
Mhm.
Do you see it work?
Yes.
Okay.
Oh,
So
oh, yeah. You see it too, right?
I don't see your screen, so I'm trusting that you see it work. And then
Um,
you,
do I do I have to? Interesting. So the left side, you always see what we both see what happens on the left side, but what happens on the right side? If I put something, you don't necessarily see it, and vice
yeah.
versa, unless I hit run.
And I believe the reason why is the left side is our file, but the right side is like locally cached. It's not a
Okay.
file. Yeah. Okay, now on the right side, can you write like 2 plus 5 or something? Like add any two numbers and click enter?
So M2 plus 5.
No, no, like just add two numbers. Add two
Oh,
any two
sorry.
numbers, and then hit enter.
Okay.
And you get an answer immediately, right?
Kind of. I kind of. Be, when I tried M2 plus 5, it gave me an error, and now it won't like. Let's see, 2 plus
Oh,
5.
once you write it
Operate.
down, it's carved in stone. You can't edit anything you have hit enter.
Okay.
Yeah.
Does clear work? No. Okay. Okay. When I do 2 plus 5, it says the operator must have white space separating. Oh, do I have to put spaces between it?
Yes. In this language, yes.
Okay. Okay. There we go. So now it works. 2 plus 5 gives me 7.
Perfect. Okay. So let me do some explaining now. So the left one, I call it the definitions window. This is where we define our program. This is our actual file that's being read by the programming language.
Mm-hmm.
Um, on the right-hand side, we call it the REPL. REPL.
Okay.
Another word you might hear for this is console. Um,
Yes, that's more of what I'm familiar with.
yeah, like in web development, if you right click inspect element and go to console, you get a console, right?
Yes.
And you can do things like what we're doing right now, where we can do it, we can type a one-line program, hit enter and get an answer immediately.
Yeah. Yeah. Like this kind of setup is more of what I'm used to like in Python.
Oh yeah, yeah. I believe Python has one as well. Yeah, exactly. But yeah, it's called a REPL, and the one in JavaScript it follows the same tradition as Lisp. I don't know if it's Lisp is so when I say Lisp, I'm referring to like this old language made in MIT. I don't know if they're the first one who did this, but I definitely know that they're one of the first ones who did it.
Like
Um,
like with
so
JavaScript, I
yeah,
would just say like execute the code on a web browser and I'd see the results that way
exactly.
instead of like seeing it over here on console.
Yeah, yeah. So there are two ways of running things. Now, a REPL, it stands for REPL. Sorry, it's
Okay.
REPL and it stands for R for read, E for evaluate. When I say evaluate, it means to turn into a value, to simplify something. So it computes the answer of something. Evaluate. P for print. So once you get an answer, you print it out. And L for loop. You can keep doing this again and again. So REPL,
Gotcha.
read, evaluate, print, loop. This is very good for getting very fast feedback. Not all languages have this feature. Uh, and while this language is designed for beginners, and what's important for beginners is very fast feedback, and so this is an important feature to this language.
Yeah.
So when you're playing around with stuff, for this language in particular, feel free to use the REPL. But in our case, I'm not going to use the REPL much actually because you can't see what I write. But in your own time, I
Gotcha.
do encourage you to check it out. Okay.
Yeah, no, it's really helpful for like complex functions. You need to test the parts that are broken.
Yeah. Um, I am going to introduce I for beginners, I don't usually introduce this, but for you, since you're slightly more advanced, I'm going to introduce it immediately. I'm going to write where into the function.
Okay.
This I don't think you'll ever see this anywhere else. Oh, sorry. Do you see this?
Yeah.
If I click run, what do you think is going to happen?
I don't even know what where it is. Like I don't know what that does.
Okay, let's click
The
run. Do
okay.
you see it?
Hold on. The test. The test in this block passed. The
Yep.
test in this block passed. Oh yeah. Okay, I can read.
Okay. So I don't know if you do you write tests in your code bases?
Yes, like my
Okay.
own person. Like yeah, I'll write like little tests in my functions to see if portions of the function work. If that makes sense.
Yeah. So usually in like programming languages, your tests are usually like you have to get a library and you like your test code lives somewhere else, maybe in a different file or at the
Oh,
bottom of the file.
sorry. I think you meant test differently than I did. I think the
Oh.
right answer is probably just no.
Oh. Sorry, when I say test, I mean like an automate a line in your code that checks if a value is expected. Like f of 1 is 2, for example.
Um, no, not really. No,
Okay.
I haven't really done that.
Oh, that's okay. So at least in my, and we're not going to get to it yet, but in my approach to teaching computer science, thinking through examples, like, is very important. Like, I might ask you, like, before you even write a function, I want you to think what the inputs and outputs are.
Yeah,
And then I want you to translate the examples into runnable code so that you can check your program.
yeah.
Yeah.
Like I would test in my own way
Hmm.
to like but I would like run something and then like I would expect, all right, like in my head, this is what I'm expecting to come out in the console. And if it comes out differently, then I'm like, all right, why did that come out differently? And I start troubleshooting.
So that's good for like certain situations, but like there are situations you want to have like a test suite where you have like automated tests. I think you can just run and it will tell
Yeah.
you to what extent is your program what you expect. That's like a
Okay.
very powerful ability.
That
Uh,
sounds great.
so there are two aspects to it. There's the learning aspect where you are learning what the function does, and as you create test cases, you are understanding it better. So that's one aspect, and that's the aspect I care most. The second aspect is the correctness of your program or the confidence you have in your program working the way you intend.
Okay.
Yeah. Okay, so this Zoom session is going to kick us out because I did not have the subscription. I'm going to
Yeah,
send
no
you a new
worries.
link on Gmail and I'll see you in a minute.
All right, yeah, sounds good.
Okay, all right. Yeah, check your Gmail.
Okay. Hey, I'm back.
Oh, welcome back. Okay.
Awesome.
All right, let's pick it up where we left off. So just to summarize what we have done so far, we've introduced numbers, arithmetic on numbers, and algebra with a computer. We can define variables and also functions.
Mm-hmm.
Oh, and a nice thing about functions is that notice how like we are able to get new numbers from it, even though we didn't touch our program. Like for
Yeah.
example, like in the REPL, if you write like f of 56 and hit enter, we get a new number, and we didn't even touch the program at all. So
Yeah.
yeah, so functions can be used to like as reusable pieces of code where you can get new things out of it without changing it.
Mm-hmm.
Okay. So I don't all this right now is all fun and great, but I wouldn't consider it really, really programming. I consider this just the mechanics of programming. I'm gonna now transition into what I consider to be the core of what we do as programmers. And what I mean by
Okay.
filling in the fundamentals, which I think universities now and boot camps don't really teach. I'm gonna delete everything. I'm gonna write a number five, and let's run it, and we should get back five, right?
Mm-hmm.
Okay. Now let me ask you, what does five mean?
Five is I can actually define it like a measurement of units, like five of something. Well, okay, you
Okay.
can't use five in definition. I think you get what I'm trying
Okay.
to say though.
Now, let me change the question a little bit. What is 5 degree Fahrenheit?
That is the number of degrees in Fahrenheit.
Yeah, but what is it? Like, what is 5 degree Fahrenheit? What is it telling me?
That's measuring the temperature of whatever you're measuring. And
Okay,
it's
temperature.
the actual measurement of degrees. Yeah.
So how hot, how cold something is.
Yeah. Yes. How
Right.
hot or how cold is on this?
How about 5 kilograms? What does that mean?
That is how heavy something is.
How light, how heavy, right? Weight, mass. So even though they're all five, they all say something a little bit differently, right?
Sure.
So there are two worlds. There is the world of information and there's the world of data. Information is ideas and facts about the real world. 5 degrees Celsius, for example. And then there's data. This is what the computer understands. Now, when we say 5 degree Fahrenheit, the computer is only going to see five, that five right in front of us right now. It's going to see that one number. It's not going to know it's the temperature, right?
Yeah.
So there's the world of information and there's the world of data. And my claim is that our role as programmers is to facilitate the interaction between these two worlds. We convert information to data and data back into information.
That makes sense.
Okay. All right. Now, I got another theoretical question. To reframe everything we've done so far, what we've basically done is we have encoded all information as numbers. Now, can we really encode all information as numbers?
Um, I'm gonna say no.
Okay, why not?
More, I'm more saying like I can't think of like in my head I want to say yes, but I'm like, oh, that could be something I'm not thinking of. I'm more thinking for that perspective.
Hmm,
But I can't think of anything you couldn't really convert into numbers off the top of my head. I mean, even colors get converted to numbers. Goodness.
colors. Okay, that's an example. Well, do you know how they say that computers are just a bunch of zeros and ones?
Yeah.
Zeros and ones are just numbers, are they not?
Yes.
So everything can be encoded as numbers, right?
I would suppose so. Like I said, I struggle to find something that you couldn't bring down to numbers if you really wanted to.
Hmm. Now here's the next question. Do we want to encode all information as numbers?
Um, if we want them to work on a computer, we do.
Okay. But are we
Or
are we always thinking in terms of numbers?
us as people, no.
Yeah.
We think I think we think of concepts, but
Okay.
like you said, computers deal in zeros and ones. And so well, that's what it's like you said. That's what we do. We translate it into a language computers can understand.
Okay. You know how they say like the universe is just a bunch of particles?
Yes.
Well, in front of me there's a table, right? But I see a table, but in the eyes of the universe, it sees a bunch of particles.
Okay.
Because as a human, seeing it as a table is more useful to me, right?
Yes.
Likewise, as humans, we think in terms that are useful to us. Like how we're talking right now, we are transmitting information to each other, but we're not speaking in terms of numbers. We're not
Right.
speaking in Morse code,
Yeah.
using words. So
Mhm.
there are other forms of ways that we can encode information, right?
Yeah.
And the reason why we want more ways to encode information other than numbers is because that's how it's useful to us as humans. Sure, we could encode it as numbers, and maybe there's a program that does convert whatever we write into numbers, but as humans, we want to see more than just numbers. We want to see something else.
Yeah, that's
So,
why, the whole world doesn't use command prompt. They use GUI.
yeah, that's an example of it. Yeah. Okay, so I'm going to introduce a new data type. And when I say data type, like number is a data type.
Hmm.
Here's another one right in front of us. If we click run, we'll get something that isn't a number. We get back a string.
Yeah.
Okay. And I can do stuff like the same way we can perform arithmetic on numbers, we can perform arithmetic on strings. I can add two
Yes.
strings together. And let's run that. Do you see hello world again?
Yeah.
Okay. What happens if I subtract? Before I run it, what do you think will happen?
Error.
Okay, because it doesn't make sense, right? If we run it, we'll see the minus operator expects to be given two numbers. Doesn't make sense to subtract two strings. So,
Could
yeah,
I'm thinking, I guess if you were to say hello world again minus again, I think I would think that could work. Yeah.
like the idea that we subtract two strings that are exactly the same.
Yeah, like if you extract if you take like hello world again and then just subtract again, maybe that could work.
Okay, like what I written here.
Yeah.
Okay,
Oh wait, let me run that.
let's run it.
Okay.
This,
But yeah. Okay, yeah. I see like it's still errors.
okay.
What? Yeah.
So
Go for it.
some programming languages are different. Like for example, some programming languages, this would be okay. It's not okay here, right?
Okay.
In Python, I believe this gives you a hello world again, hello world again, hello world again. Like it actually repeats the string three times and glues
I
it all
think you're right,
together.
yeah.
So, and JavaScript is designed to be run on the web and it's designed to not crash as much as possible.
Yeah.
And so in JavaScript, you can do all sorts of crazy things. Like JavaScript, you can do things like, dude, I don't even know, man.
Dude, you could
I don't have
like
it.
no JavaScript, you'll just straight up miss grammar and the web browser will be like, I think you meant this. Like sometimes.
Like JavaScript is very forgiving. You can like do like strange
Yeah.
like math operations on things that are not numbers and it will work
Yeah.
because it's designed to not crash as much as possible. Anyway, all this is to say that we can perform quote unquote arithmetic on strings in the sense that we can perform operations on strings, but those operations are fundamentally different than on numbers. Yeah.
Mm-hmm.
I'm going to introduce another data type, Booleans,
Booleans. Oh.
right? Because it encodes decision like strings are used to encode like words, language, text. Booleans are used to encode decisions, yes or no, true or false, on or off. It could
Yeah.
also be understood to encode truth. So if we run it, we get true and false back, right? These are actual values.
Yeah.
Note that true and false are special citizens in this language. If I write true equals 5 and I run it, it's going to say, whoa, I don't understand this, right?
Yeah. Which makes
Different
sense.
languages will have different outcomes here. I think in JavaScript you can actually do this. I could be wrong though.
No, I don't think so. Again, it's been a long time. But no, I think it's like you said. It's like there's special words that are set aside. You can't
Yeah,
make them into variables.
exactly.
True and
Yeah.
false are two of those.
Okay. So far we've introduced three data types, and for Booleans, there are Boolean operators. I believe this should be familiar to you, right?
Okay, yeah.
Yeah.
Let's see.
Um,
Uh, um, maybe not so much. So, like when you said what you said, true and false, and that came out is false, was it?
yeah,
Why did that come out that way?
that's a good question. Okay, I'm already sharing my screen, but I'm gonna share another window. I'm going to
Okay.
show you something else. Give me 1 second. Yeah, I found it. Okay.
So I guess
Where
because something can't be true and false, so it's false.
you're close. I'll say there is correct, depending on what you mean by that. Okay, so do you see my screen?
Yes.
So on my screen here is a truth table.
Okay.
Well, a bunch of truth tables actually. And so these are the definitions for what does arithmetic mean for Booleans. How do we combine Booleans together? So for
Okay.
example, like n, the n truth table, it tells us 0 and 1. So 0 is false, 1 is true. Is false. The
Okay.
short answer to your question is that's just the way it is. The more nuanced
Okay.
answer is that these are these are all the possible ways in which different combinations of zeros and ones can produce certain values. For example, for n, 0 and 1 is 0. For r, 0 and 1 is 1. And we assign names to these tables. Okay? Why is n called
Yeah.
like this? If I ask you, do you have an apple and a banana, but you only have a banana, you'll say, no, I only have a banana. For
Yeah.
or, I ask, do you have an apple or a banana, but you have a banana, you say, yes, I have a banana, right?
Yeah.
So that's the
I think
intuitive answer.
yeah, that makes sense. Let's see.
Mhm.
What is that third one? XOR. I'm not familiar with that.
Exclusive or, it's or, but when they're both ones, it's zero.
Okay.
Yeah.
Can you like frame that in a sense like you did like for and and or?
Uh, Let me think about this.
I think I get the concept, but I don't know if that would also help. So
It's like when you can only have one item, but you can't have both. Like
yeah, it's
like let's say like
exclusive.
my mom asked me, do you want ice cream or waffles? I can't say I want both, right? My mom will be like, what? No, you can only have one.
I see.
That's an example of exclusive or.
Yeah. Okay. I get that. So if you have one or the other, it's fine, but if you have both, that doesn't work.
Yeah,
And if you have neither, then it's just false.
exactly. Yeah. Okay, so in some sense, these are functions. They have inputs and they have outputs, right? In fact,
Yeah.
the words are in there, inputs and outputs. In programming, it's a little different. They're not exactly functions. They're conceptually functions, but what makes them not functions is the idea of short circuiting. Have you heard of that term before?
No.
Okay, never mind. We'll explore that in the future. Uh,
Okay.
on top of these tables are logic gates. These are physical devices that give in electrical signals, like whether or not if like electricity is flowing in a wire, it will produce a certain output. For
Okay.
example, for the AND gate, if the electricity is flowing in both wires coming in, there will be electricity flowing out. These are the
Okay.
building blocks of our computers. Our computers are made with thousands, hundreds, thousands, millions, billions of these little things.
Yeah.
Remember how I said computers are the zeros and ones? These are
Yeah.
the zeros and ones. Our
Yeah.
computers are a soup of zeros and ones, and these logic gates are constantly stirring the soup, transforming zeros and ones into different zeros and ones, which what allows computation to happen.
Okay.
Yeah. Uh,
Um, what
yeah.
about the other three? If you're okay with going through them. If it's not time, it's not time. But
These other three? Okay, so
hmm
this is not and. This is and,
okay.
but not it. So not and, like nan, is a combination of not and. Notice how
Okay.
like you flip the outputs. Nor is not or. It flips the outputs of or. X
Okay.
nor is exclusive. Is not applied to exclusive or. Yeah.
Okay.
So these are the arithmetic of Booleans. This is how Booleans can combine.
So with this, when you write this in VS Code, does
Yeah.
it write just like that, like false, XNOR, and false, and then you get true?
For Pirate specifically, Pirate only has not and an R.
Okay,
Other languages may have more of these.
okay, yeah, yeah, I'm
Yeah.
cool with that. It keeps it simple.
Okay, like for example, let's jump to VS Code real quick again.
Sure,
And I do have to wrap up soon.
no
So to
problem.
write not in Pirate, we just okay, you have to put the parentheses, because again, ambiguity. If we click run, true and true is true. And then oh crap, I deleted everything. And this
No
whole
worries.
thing is going to be
Ooh, my bad.
false
Hit that too
or
soon.
false. Yeah, you see all this?
That comes back in true though.
Yeah, because so if you think about it, this whole parenthesized
True
expression
and
is true,
true
right?
or false. Yeah, yeah, that makes sense.
And then true or false is true.
Yes.
Yeah, so this is the arithmetic of Booleans. Okay,
Hmm.
so for homework, and okay, since you say that you want structure, I'm giving you homework. I usually ask people, do you want homework for you? I'm giving you homework. I'm
Okay.
gonna write this question down for you. Okay, wait, before I write the question down, I'm gonna write these two things. I'm gonna run it. You receive
All right.
five in string and five not in string, right?
Yes.
So my question for you is, now that we have strings, and strings are a series of characters, and to write a number, we have to write a series of characters. Why do we need numbers? Why do we need a second thing? Why not just use strings for everything?
Because you can't like, well, you kind of can't. You when you run formulas, you need numbers. Like numbers are used for formulas for the most
Okay.
part.
Okay, I want you want the right idea, but I want you to formulate a proper response. Like think about
Okay.
it and like formulate a proper response. Okay, I do have to close now. I'm gonna email you some recommended exercises. Now, I'm not going to like force you to do them. Like I'm not gonna say you cannot book a session until you complete them. Like this
I understand.
course, no, not this course, this like sessions is self-paced. Like the pace in which you go is completely up to you. But
Okay.
since you want structure, I'm gonna be extra strict with you and say like do your best to find a time, even if it's tiny cracks in your schedule to find a time to do them. It will be useful for you.
Okay.
Um, Okay, I'm going to wrap up now. I like to end my sessions by asking the student, what is one thing you learned today that stuck with you?
Oh, a bunch. Just kind of going through the Booleans and seeing how and or function together with the Booleans, and even yeah, like I didn't even know like X and N and existed until today, but now I know
Oh,
they
yeah.
do, and that those are like things. So yeah, I'm like learning about new concepts.
Awesome. Okay, I'm going to wrap it up here. Thank you for joining me. I'm very happy to be able to help you on your journey to learning programming, or at least relearning programming. And you can find this recording on YouTube. You will find your name on it. And I hope to see you again.
Yeah, definitely. We'll link up again. Yeah, appreciate all you teach me. Thank you, Marvin.
No problem. All right. Bye bye now.